mirrors on the James Webb Space Telescope have components attached to the back of each of them. What exactly are these and what do they do? Well, we're here at Ball Aerospace in Boulder, Colorado to find out. So Brad, what's going on over here now?
Well, we are bonding items to the back of the mirror, and that is to distribute the loads during launch as well as to distribute the loads during the mission.
And this is a precursor to more items being attached to the mirror, right?
Yeah, that's correct. The next step is when we attach the hexapod assembly and the radius of curvature subsystem onto the back of the mirror.
Sounds like a mouthful. I think it'd be better understood if we actually see one.
Sure. The hexapod assembly has the 6 rigid body actuators. Its job is to manipulate the mirror in 6 degrees of motion. The radius of curvature subsystem, it's one of the 6 struts, and there's an actuator that goes to the center of the mirror. It can very precisely change the radius of curvature of the primary mirror. Because the mirror consists of 18 primary mirror segment assemblies, those 18 primary mirror segment assemblies must be adjusted while on orbit to mimic a perfect primary mirror.
So Brad, can we take a closer look at these actuators?
Talk to Jake Lewis, and he will bring you up to speed with the actuators.
Jake?
Yes.
Yeah, Brad told me that you are the man with the actuators.
Absolutely.
Can we take a closer look at them?
Sure. So here we have the hexapod, and we're aligning the actuators onto it. A precision alignment fixture allows us to build each hexapod identically. Now that they've positioned the actuators on here, they've got to verify that it's in tolerance. So they're measuring it to make sure that it's in the exact position that it needs to be.
Do you have different actuators for the different mirrors, or are they all the same?
No, one of the things that we've done is that all of the mirrors have exactly the same actuators on them.
Secondary, tertiary, all those?
Just the secondary and primary mirrors have actuators. The tertiary doesn't have any actuators on it. It stays fixed. But the only difference between the primary and secondary mirror hexapods is the size of the frame. The actuator assembly all remains identical, and that's a cost savings and a great simplification for us.
Well, thanks for giving us a sense of what actuators are on the James Webb Space Telescope and the hexapod assembly.
You're welcome.
As you can see, these actuators with the hexapod assembly make these mirrors on the James Webb Space Telescope much more complex than the ones that, say, you might have in your bathroom. But these mirrors have a job to do, to look at a universe billions of light years away. Thanks for joining us for another edition of Behind the Web.